discuss some of the more basic approaches to integration before we get into some of the more difficult operations and different ways we can integrate. And we'll start by just talking about a few integrals that we should already know to kind of give us the background to be able to do some of the other ones that we want to do. The first one, the integral of a constant k is just kx plus c. So the integral of 5 is 5x plus c. The integral of -2 is -2x plus c. These are things that we should have been doing already, so we should be comfortable with. The second one is our power rule. The integral of x to the p is 1 over p plus 1, x to the p plus 1 over c, provided, of course, that p is not equal to -1. So as long as our exponent is not -1, we can add 1 to the exponent and then divide by that number. If our exponent was equal to -1, we can see that that would cause us to divide by 0 here. So we'll consider that case shortly. The next one, the integral of cosine of ax dx is 1 over a sine ax plus c. So anytime we're integrating cosine, if there is a number with the x, we just simply need to divide by that. Similarly, the integral of sine ax is -1 over a cosine ax plus c. Since the derivative of cosine is negative sine, when we integrate sine, we get a negative cosine. The next one, the integral of secant squared ax is 1 over a tangent ax plus c. Since the derivative of tangent is secant squared, the integral of secant squared is tangent. We also have that the integral of cosecant squared ax is -1 over a cotangent ax plus c. The next one, the integral of secant ax tangent ax dx is 1 over a secant ax plus c. Because we know that the derivative of secant is secant tangent, then the integral of secant tangent would be secant. On the other side of that, the integral of cosecant ax cotangent ax dx is -1 over a cosecant ax plus c. So these are all of our integrals of trig functions that we should know. We also have our integral of e to the x. In this case, we're going to write it as e to the ax is 1 over a e to the ax plus c. If there's a number times the x in the exponent, we just need to divide by that. Next, we'll look at the case when the exponent on x is -1. The integral of 1 over x dx is the natural log of the absolute value of x. And that absolute value is important since we cannot take the natural log of a negative number. The next one, the integral of 1 over the square root of a squared minus x squared dx is arcsine of x over a plus c. So this is the inverse sine. And I will use arcsine because occasionally I want to use sine to the -1 to mean cosecant, and I don't want to get confused using a -1 power as both meaning cosecant or inverse sine. So we'll use arcsine and arccosine to indicate the inverse. The integral of 1 over a squared plus x squared dx is 1 over a arctan of x over a plus c. So if we get rid of the square root and change the sign, we now have the inverse tangent. And then our last one, the integral of 1 over x square root of x squared minus a squared is 1 over a inverse secant of the absolute value of x over a plus c. And now we'll use these along with some operations that we have already talked about or some algebra to look at integrating other things. Here we have the integral of 1 over 7 plus 4x dx. One of the things we've already looked at is u substitution, which is exactly what I want to do here. I'm going to let u be equal to 7 plus 4x. So du would be equal to 4 dx. Since I don't have a 4 dx in my problem, I'll divide both sides to get -1/4 du, or +1/4 du. So that gives me 1/4 the integral of 1 over u du. Well, we know the integral of 1 over u is the natural log of u, plus c. Therefore, my final answer, 1 over 4 natural log of the absolute value of 7 plus 4x plus c. Here's the next one we want to look at. And if we only have a single term on the denominator, it may be helpful to break this up to be the square root of x over x plus x to the 5th over x dx. This now becomes the integral of x to the negative 1/2 plus x to the 4th dx. Here, we'll add 1 to the exponent and then divide by that number, plus add 1 to the exponent and divide by that number. So we have 2 square root of x plus 1/5 x to the 5th plus c. Next, the integral of x squared plus 4x minus 2 over x plus 3 dx. Usually when people see this polynomial, their immediate thought is to factor. However, if you notice, we actually can't factor the polynomial in the numerator, so we need to use something else. And in general, anytime the degree of the top is higher, we can use polynomial division. So I have x squared plus 4x minus 2 divided by x plus 3. I know that I need to look at the leading terms, so let's start. X times what is x squared? Well, x times x is x squared. If I multiply down, I get x squared plus 3x, and division says I then need to subtract that number. 4x minus 3x is x minus 2. X times 1 is x. We then multiply and subtract to get negative 5. Therefore, this is the integral of x plus 1 minus 5 over x plus 3 dx. I know this is 1/2 x squared plus x minus the integral of 5 over x plus 3 dx. For this last part, I can let u be equal to x plus 3, and then du is just equal to dx. This then becomes 1/2 x squared plus x minus 5 times the integral of 1 over u du, which then gives us an answer of 1/2 x squared plus x minus 5 ln of x plus 3 plus c. Here I have another one with this polynomial, and once again we can figure out pretty quickly that factoring is not going to help. In fact, here instead I'm going to want to complete the square. Let's look at just this thing under the square root for a second and look at completing the square. We always start by taking the number in front of x and dividing by 2, and then squaring. If I divide 9 by 2, I get 9 over 2. Squared is 81 over 4. So I'm going to both add and subtract 81 over 4. That way I don't actually change the problem, since I'm just adding 0. For the first part, I actually need to subtract negative 2 plus 81 over 4. That gives me 73 over 4. And for the next part, since I don't like a negative in front of the x squared, I'll actually factor out a negative sign to get 81 over 4 minus 9x plus x squared. I now have 73 over 4 minus 9 over 2 minus x, all squared. And now I can move back in terms of my original integral. I now have 73 over 4 minus 9 over 2 minus x squared, all to the 1/2. And then to make it look a little bit nicer, I'm going to let u be equal to 9 over 2 minus x. So in this case, du is negative dx. So negative du is equal to dx. Therefore, I have negative the integral of 73 over 4 minus u squared to the 1/2 du. And the reason this is now helpful is because this looks a lot like our integral that gave us arc sine. So we now have negative arc sine of u over this 73/4 is a squared. So over root 73/2 plus c. Moving back to terms of x and doing a little simplification, we get that this is 9 minus 2x over root 73 plus c.